pretty nice. Alright, so the next step is I gotta take the new blank, the new blank, and I gotta start putting these beads in here. I haven't quite finished some of the welding and stuff on this. There's some finish work and stuff to do. We'll go ahead and take care of that after we get that patch panel over there put together. But I think I'm gonna try something and combine a couple of different videos here. I want to make a 3D printed stamping die to try to at least get maybe these two. So what I'm going to do is I'm going to trace all this out. I'm going to make a pattern of the depth. And then I'm going to go back home, fire up the 3D printer, fire up my software, and I'm going to make a die out of ASA, which is like ABS. 100% infill, and then I'm gonna probably try to stamp it out on my hydraulic press. I know audio hasn't been great on some of these videos, and hopefully I can get some monetization out of this stuff, start making some money doing these videos. I can buy like a lapel mic or something so you can hear me better. But until then, you'll just have to suffer along with me on the audio. I think what I'm gonna do is I'm going to make a die that carries both of these, and it's probably a little tough for you to see. I'll get some stills here and overlay them in. There's part of this is the original floor from the 56, and then these are pieces that I made by hand years ago. I've got better tooling and stuff now to make these two shapes better. I think what I'll do is I'll make my die maybe with a couple holes through it that I can bolt them together. I can drill out a couple holes, put the top and bottom piece on there, and then I can reform some of this. But what's interesting is the factory divot here is not square. It's got a taper. It comes up. So it's got like a radius in here. And I can put that in with the die. Doing that by hand, you can do it too. It just takes more time to make it happen. But this end, because it was right up against where this seat support is, I really didn't have a whole lot of options, so I tried making a tighter radius and more of a square area, and I'm not super thrilled with how a lot of this came out, but we'll clean it up and we'll make it look right. Again, my goal here is to try to make this look as factory as possible, and having big ugly welds and hammer marks and beat up stuff all over it, not my style. I want it to look better. I mean, most guys overlap it, MIG weld it, bury it in mud, bed liner, whatever it takes. So we'll go ahead and we'll dimension all this stuff out, and then I'll pick the depth, and then I'll go ahead and take this stuff home and we'll get started on the next part. So usually the best thing to do is just a one-to-one drawing of exactly what you got going on, right? So take a piece of paper and you're gonna lay it right over the top of that, and then just take your dirty finger and you can trace around the open hole, and it'll leave a little bit of a mark on where those holes are. No, it just makes dimensioning stuff just a little bit easier. Probably can't see that all that well, but lighting is what it is. So, tape measure, my kangaroo pouch. So we can go peak to peak to peak, so we know where everything's at. And as typical tape measures, right? The ends are, you drop it a bunch of times, it's hard to read. It's supposed to be loose like this. I don't know if you know that, guys. I don't know how many times I've seen people get frustrated. They're like, this tang is loose, this thing's bad. Well, yeah, it's an inside or depending on where you're pulling your dimensions. So it's an engineered amount of slop, right? The engineer in me is like, forget that first inch. We start at our 1 inch mark, and this is where everybody makes a mistake, right? Is they start, they measure from the 1, and then they measure, okay, well that's 2 3/4, and they write 2 3/4 down. Well, no, it's only 1 3/4 because you're chopping that first inch, right? It could be, you can really bite you in the ass. I mean, even if you know what you're doing, you'll still forget every once in a while. So we'll kind of dimension that here. And this one. All right. So and these are, our outer peak is 1 3/4. 1.75, and that's the same. Oh, actually, this one is smaller. So that one, 1 5/8. Yeah, I guess they're both 1 5/8. All right. It's tough to tell because you were on the outside of the radius. We're trying to guess what the inside platform should be. So let's make it 1 5/8. So 1 5/8, and then our overall 4.5. So when we're pretty much in line here. So then, what the inside, the bottom of it, looks like 1 3/16 at the bottom. So 1.1888. If I could write, right? And then it's about 2 wide. And then depth. People give you weird things after a while, right? So I got these. I got a couple of them. Really cool old leather pouch. I really can't make out what there's. You can see there's a logo right here. I really can't tell what it says on the outside, but it's a pit gauge for pipe welders, right? So you've got a little spike, and there's a gauge and everything. It shows you what it is. It's pretty neat. It's got a scale on here. It tells you how deep the pit would be. So we can put that right on there. Push it down, and 5/16 more or less, right? So that's one way to make that. The other is an old school adjustable square, right? So then we can look at that and go, okay, yeah, that is about 5/16, maybe just a little under. So 5/16 would be 3.125 deep. So 0.3125 deep. All right. And the next thing is trying to figure out what this radius would be if we were going to make it something really accurate. I don't know. I mean, probably a couple of ways of going about it is make a cardboard template of it. But it's also not a bad thing. You can measure your enter and exit on it, so you know it's about 1 1/4 on that radius. So from here to here, we're about 1 1/4. All right, so we got some dimensions. Let's go design some stuff on the computer and print some stuff in 3D. All right, so we got our notes, and we're gonna start. I'm using a Libre again. You can consider this part of a tutorial.
we got to make the dies, right? So we're going to do a top and bottom, and I think I want to put like 2 bolt holes through the middle of them so I can like reshape those 2 on the driver's side that are just malformed. So we'll start off a solid part. Takes a little bit to render. Alright, so now one of the weird things about I've been learning Fusion at work, and one of the things is a Libre. I don't know if you can see down here in this bottom corner. The Z-axis is on a horizontal. I don't know why a Libre does that. It's the way it's always been. So when you design something, keep that in mind. The front on the toggle cube up here in the top there, that's actually the top. In this world, the Z-axis is horizontal and the Y-axis is vertical, I guess, right? Doesn't really matter a whole lot. So anyway, pick a plane, our XY plane. We'll activate a sketch. And I don't have a preset on this one, so I'll have to go through and I hit the reset view kind of thing. So now we've got into a sketch mode. So let's go ahead and pull our rectangle tool, and we'll draw just a basic rectangle. And don't worry about dimensions or whatever. Now, I'm used to my keyboard shortcuts and stuff. I don't know a whole lot of them because it doesn't matter in Libre that much. But if you hold your 2 mouse buttons down and the shift key at the same time, you can pan. Or if you hold your left and right mouse buttons down without the shift key, you rotate it. Alright, and then we hit reset view and it snaps back. So I don't know if anybody is used to that. I know in Fusion you can do that and you can make it work that way, and it's not their default. They've got their own way of doing things, so I just struggle. Let's make it happen. So we know our die set is going to be 1 5/8 inches wide. So we need our base, our platform that we're going to build, we need it to be bigger. So like 2.5 would be a good width. So let's do that, because we're just going to do one of these at a time. I thought about it and I thought, well, you know, I think that's going to be the better solution to this. Now, you see it shortened up on one side here. And it's offset, right? So there's a couple tools. Up at the top, there's a symmetrical constraint. I like that one for a lot of this stuff. If I'm not going to be like rounding the corners and stuff off, and there's a couple ways to do that. I can show that stuff down the road here. But that one works pretty good. We're making a platform, and then we're going to radius some of the corners after we process this thing. So let's just make the punch, basically the piece that'll go into the top. That's the part we're going to make. So our overall length is, let me do this. Let's put another rectangle in here. Okay, and then select, highlight everything, right? And then right click, convert to a reference figure. So now you see it's a green dashed line. So when you do any more functions with it, that is just like measurements, right? So let's go ahead and let's centrally constrain this one, and then dimension it, right? So that is 65. And then our height is 4.5, right? So let's do our symmetrical constraints. Scroll wheel is your zoom, right? So pick our midline and our outer pieces. Okay, so it centers that one up. Let's center the block that we're going to build here. Okay, so now we've got, this is our reference, this green line frame, and then you see the red, orange, and then they'll turn black when they're fully constrained. The red ones are because we don't have any dimensions, of oranges because we do have a side dimension on it. That's our 2.5 here. Come on. So we know that that's what that is. So you can drag that, and then you can kind of get an idea. So we know that our wall thickness is 7/16 of an inch, right? So let's make this the same. Let's make that 4375, right? Okay, so now you see it's all turned black. Now hit deactivate sketch and extrude and put it into perspective. So default, it's 5 inches bossed. So you can change that while you're in this window. I only want it, say, 1/2 inch. Or if we want to go the other way, because we're gonna make the punch, right? So we want to reverse it. So you hit the reverse tab, pushes it out onto the other side of your plane, your working plane. Okay. So now that you got like a basis, it's really smart to just start saving some of this stuff. And let's go. There's my. I catalog everything. I try to put everything into folders, and if you don't, you get a big mess real quick, right? I thought I had just a. Oh yeah, right there, 53, 56. So extra cab truck, and we'll just call it floor. I've done a couple of them there. I already saw some of those, right? So we just call it rib punch A, right? So we know we get the small. Now you could go through and you can hit your fillets, and you can specify how big you want your fillets to go, right? So you can go right on those edges. If you're gonna make a punch, having softer edges is gonna leave fewer marks in your metal when you're done. Okay. So then the other one is we can hit right on the top, and I want to reduce that, I don't know, 1/8 of an inch, because I don't want that big of a radius on the top of that. So now you can see that's our piece, right? So now we need to make the form. So a couple of ways to do this is let's pick our ZY plane, activate that sketch. Okay, and then, oops, hit the wrong button. Hit caps lock instead of shift. All right. So just go ahead and start kind of sketching out what we're gonna do. And remember, we've got that radius that we got to deal with, right? And then go into our arc tools, and there's a tangent arc. So we can select that line and do that. So now we've kind of got a basic shape of what that is. We're going to edit this here. That's where it's coming up close to the seat platform. So let's go ahead and dimension. So we'll pick our plane. Alright, so that gives us, that's another way to centralize that. I could have done a symmetrical constraint on that, but for this, because it doesn't have 2 lines that it's constraining, it's just got 2 points. Sometimes it can fail, it can lose that dimension. So we're going to do it that way, and then we'll make sure that our baseline is right on that axis. I'll lock that down, and then our depth was 5/16, right? I did write that down. I know I said it and I forgot to write. Oh yeah, there it was right. 0.3125 deep. So we got that. Now, let's put the radius on this, because this is going to make doing our constraints easier. Right? So see, it doesn't want to do it that way. You can drop that radius down, and then pretty much anything bigger than that, because it's doing this as a square. Well, it's not square. So drop that, and then we'll go back to our radius tool, right? And I like this one, right? It's the circular arc start to end radius. So we can go right off of our point, and then we can pick another area, and then we can just drag it and create that radius, right? And see, it auto constrains. It put a tangent constraint right on the panel. You can see everything's highlighted in blue there. So now we can go through and trim tool and knock out all the other extraneous stuff. So we know that the bottom die, the bottom footprint, the flat part, that was 1.188 inch and 3/16, right? So now, I'm sorry, I did the wrong dimension. So it's 2 inches. Okay, and then it's inch and 3/16 long. So let's grab our tool. We can move this and see how the radiuses change. Now, one of the things I did is I measured basically from point to point, and I came up with 1.25 inches, right? So that gives us our radiuses. That's how we know what our radiuses is, and that's also 1.25 inches. So now we kind of got an idea, and if we want to change something, see this one's in parentheses here. That means it's just a non-editable dimension. The ones that are not in parentheses, you can hit edit. I'm just gonna do it. So say we want to make this 2.25. See, it changed it to 1 inch. Okay, so that works out pretty good. So, and then hit Control Z, undo it, it puts it right back where it was. So deactivate, everything's in black now, and then we go back to extrude and roll it so you can see exactly what's going on. Now, this is the 1.188, right? So now it's offset, right? Edit. You could have done this before, but up at the top here it says mid-plane. Hey, look at that. So that is our punch, right? But we want more of a zero clearance on this. So hit our chamfer tool, and we can hit chamfer, and you can do it in a couple of different ways. Our overall was at 1.5 inches, right? So we want to get out to that. So we can do a little bit of math, right? So get your calculator opened up. And 1.625 minus the 188 equals divided by 2, right? So that is our dimension. So we want to go back in. I'm going to take this off the screen just so you don't have to look at it. So equal distance, distance. Okay, so we got to change this. One is going to be 0.2185, and then the other one is 0.3125. Yeah, look at that. Perfect. So put it on the other side. Look at that. It auto-generated it all. Alright, close. Oh, shit. I forgot to hit save. Apply. Okay, so save it. It's important to save as many times as you can. So now we want to go through and put some chamfers on things. 1/8 inch is good. You can pick multiple, apply. And then around this, it's got to probably be a little bit bigger. It's a top radius. So you got to think about like the top and bottom of the metal. So when we're looking at, that's how it's going to push down into the sheet metal, right? So that's our basic die. Save. That's our punch, sorry. That's our punch. Now, we want to put a couple holes in it so we can kind of bolt it together, right? So just pick your XY plane again. And now we're just going to do a couple holes. And it really doesn't matter where you put the holes. And make those equal. Sometimes it'll auto constrain, sometimes it fights. We're going to equal constraint. And now we'll start dimensioning them. 5/16. Alright, and then I'll put a distance on these. So let's make them 2.5 right there in the base of it. Alright, and then, oh yeah, see they're orange because they're not locked to that middle line. Now they are. So you can go ahead and continue even if it's not constrained, but just be aware that if you do any processes down the road that those holes could have moved one side or the other, right? So deactivate, and then we're going to extrude all the way through all. Okay. All right. So now we've got that. So that's our punch. Save it. All right. So now that's going to be the piece that pushes down. We're going to form that little mini ripple like this, right? So I'm going to put a B, because this is the back of the vehicle, right? So I know which radius is which, because remember the radiuses are no, the radiuses are the same, so it won't really matter. I'm going to put it on anyway just to show what you can do with this. Text, just put, and then we got to shrink that down. Apply, and then we can constrain it. There's a coincidence constraint right on the middle there. Oops. One. Let's go higher. Yeah, see that? See that? It does this every once in a while. You hit edit and it doesn't actually do it. There we go. I like that better. Okay. So now deactivate it and then extrude. And we just want this to be like 50 thousandths. We don't want a huge. Wait, did I hit the wrong one? Wait. Why is it doing that? There it goes. All right. I don't know what I did there. So now we've got our top punch kind of drawn, right? So let's save this as B. We're going to call it die. Okay. So now we've got a lot of this stuff already drawn, right? So let's knock the fillets out. Just suppress them because we might be able to reuse some of those. Alright, so now let's go ahead, and this is our progress bar. Fusion, I think you'd call it progress bar, right? Timeline. We can move it up and down on this one. So now, our extrusion, let's reverse it. Alright, and let's make it a little bit thicker because we're going to make a hole in the middle of it, right? So now we make our radiuses, okay. And again, the fillets on that side, and that's good. So now this one is the problem. Now I just made this inside. So now let's delete that, and then let's do an extrude. Same dimensions, mid-plane, right? Mid-plane 1.188. Okay. So now we got our pocket. And then let's see if we can get some of these edge chamfers to come back to life. Unsuppress them. Nope. So let's edit. Look at that. It did it. Okay. And just pick that edge. Okay. Alright. Now, there's a problem I've already introduced to my issue here. The depth is going to be okay because we've got the thickness of the metal, but the width is not. So the material we're using is a little more than 50 thousandths of an inch thick, right? So let's go back to our extrusion, and we can actually do math right in that window. So that's just going to be on one side, so you actually need to make it 0.1, right? 0.1 inches. Look at this. Okay, so now we drag our little progress bar down. So now it's wider, so as the punch comes down, it pushes the metal in. It's got room for the metal to go inside. So now, let's see if we can get some of our fillets to come back to life. That was these guys, right? Yeah. So let's change that to the bigger radius. Let's make it 0.175 for the thickness of the material. Right. And then the next one was the outer. Right. So let's go ahead and we're going to decrease that one to just 200 thou, because we'll take that 50 thousandths radius off of there. Okay. So then we can go all the way down. So we don't want to change the back. Now we can leave the back on there because it's still the back, right? So that's a quick way of getting everything put together. So now, let's close that out. Let's make an assembly. We can just check our clearances. Where did I put them? I forgot what I just named them. Nuts. What did I name it? I can't even fucking remember. Floor rib. Jeez. My old brain. Insert design. Floor rib. Where did it go? There we go. Floor rib A. Don't worry about where they go. Just put them on. Okay. So now we can see our two pieces. So probably the easiest thing to do is hit our constraint and then pick our plane. It's kind of hard to see in there sometimes. Just zero it out, and then our holes are a good centering device, right? And Okay, come on. And we do another constraint. We put the two faces together here. And we're going to leave a 0.05. Come on. Alright, apply. And then we're going to lock these guys together. So now we've got these now we need to check what's going on. So let's save this. Right, so now we need to add in a section view. So let's select the two pieces. And I want to pick my Z-plane. Okay, now when we look at that, we can see we've got a nice clean path of 50 thousandths all the way through this. Right? So you can hit Control M, get your measurement tool, and you can pick these edges. And it should show you 50 thousandths of an inch right there at the top. Pretty cool. So just make sure that we've got everything put together pretty nice. And then we can hide that one. And now let's do another one. Let's add another one in the original plane. And the two parts that we're going to section. And then we can look and we can see got a little bit more gap on the sides, right? So 73, because it's at an angle. So that 100 thousandths that I added into the die is too much. So let's drop that down to 7.5. So edit here, right? Edit here. Let's cut here. So let's edit that down. So it's got our 0.1. So let's just change that to 0.075. Okay. Close is going to be good enough on all this. Generate the last feature. Save it. And then we go back in. 60 thousandths. So that's not bad actually. If you make this too tight, you can actually start creating other problems for you. You want this impression and this impression to be a little bit tighter. You're trying to get those radiuses in there, so the angle might not be exactly the same. You can change the radiuses on some of these if you want. I'm going to leave that there as just kind of as to what it is. Let's hide that again. Alright, so now we need to turn these into STL files, right? So we want to edit this in a separate window. Okay, and then we'll go into our export tab. Just an STL file, so we're going to 3D print this stuff. And we need to put it into the right file. I've got a lot of stuff preset on there as far as like faceting and stuff. you're going to have to experiment a little bit when you're taking your designs and pushing them out, because if you get too many facets into something, it can really slow your machine down. If you've got a good machine, it'll handle that stuff a little bit better, because the finer, the fewer facets you have, the rougher, the more origami looking it would be. So you want to put as many in there as you can, but there's a certain point where it's just like, it's just useless. So that one rendered out good. So now we do the other one. Nope, wrong one. Crap. Will it do it? Let me see if I can export it. Oh yeah, it did it. Okay. Nope, take it back. It did not. Crap. Direct last feature. Come on. Poop. Okay, so this one, I did this one, right? STL. See, die A is in there, die A is in there, okay. We've already done die A, we need die B. What is going on? Where is die B? Oh, punch. Where's... Crap, that's what it did, didn't it? I just screwed up. Naming schemes makes everything. Let's see, what did I do here? Punch A. Okay, let's try that. I sometimes I'll just name it punch and punch, even though there'd be like A and B, because it's just easier that way sometimes. So die, punch, good, we got it. Alright, so, and then again, here's that STL thing I was talking about. So I've got a deviation of a half a degree, and then our surface level is 5,000ths of an inch. So it's like everything, any step is going to be within those, excuse me, within those constraints. Anything finer than that on a 3D printer, you're never going to notice it. And there's on Cura, which is the one that I use, it will go through, and the resolution's not that good anyway. You're dealing with a 0.04 millimeter nozzle, which is 50 thousandths or less, right? 30 thousandths, yeah, it's pretty small. So it just, the render is going to be finer than the machine can actually produce. Coffee. Alright, so I did it. Alright. Now we can close those out. Alright. So this is what I printed a couple of these for my Echolt out of ASA. I've been using carbon fiber nylon, and I'm having a rough time with it. It's not, the layer adhesion's just not that good. I've had a couple failures, and then I printed these out of ASA yesterday, and they worked really good. I got, I had one put together and I ran it, and then I had a failure. That actual tool holder from Echolt broke in half, and now I gotta buy another one of those. I really like my plastic dies for these, for the Echolt machine. So to get back to what I was going through here, so one of the things is this. This is called an auto temp tower. It's something you can get in Cura here. So go to extensions and then auto towers, and then I did one for ABS because ABS and ASA are very similar. ASA is a little more durable as far as like weather resistance, and I think it's got a nicer finish than ABS can have on it. It's not bad. I bought this particular gray ASA for making exactly stuff like this. I've got another project that I've been working on where I'm building a custom steering wheel, and I'm using it to create die holders for the wooden grips. So we're not worried about that right now. But anyway, do a temp tower, and on the side here, it'll tell you, it's right here, it'll tell you what temperature it was. And I found out I've been printing at 250 because that's like the recommended. But if I went through and I look at my bridges, and the 240 actually, so 250, 245, 240, 235, and it just gets cooler as it goes up. The 240 is the most complete. You're not going to see that, but as far as like the filament hanging down and the most infill and stuff on the top, the 240 was actually better. So I printed those hammerheads in 240, and adhesion between the layers was really good. The finish on it was some of the best ASA print I've ever done, and so I really implore you guys, if you do any 3D printing, do temp towers. I've got the printer here next to me, and we'll go through that as a next, and I'll try to set up a time lapse so you can kind of see this thing print. So let's open these up. Yeah, there's our old stuff, right? So let's go back into where, and it is, there we go. There's our two pieces. And you can see all the old drawings and stuff that I've put in there. So let's open them up. And hopefully they lay down the right way. If not, okay, one. Where's the other one? There it goes. Alright. So let's move this one over. And this one, we need to flip it because I want the die side facing up. Pick that. There we go. So now hit arrange. And then hold your shift key down, and you can center them back up on the plate. I like keeping them in the middle of the plate better. Just looks nicer. That's where all the glue is on the print plate. Alright, so now we can slice it. So everything is already picked up in Cura. I've got my layer height at 0.15 millimeter. I had to drop my initial layer height, so I've got a little bit better adhesion. And that bottom layer on the print, actually turns out smoother. Because if you have a 0.3 millimeter, it has like zigzags and stuff, and there's little voids and stuff in there, and it doesn't want to stick as well. So, like I said, drop that down, and I get better. And then, as far as everything else goes with this particular material, my infill density is at 100. There's my 240 for the print temperature. I'm going to be in the way on some of this stuff. I've got it at 70 millimeters a second for travel. I've got a retraction in it to keep from stringing so bad. I've got generate support on this. There's not any support needed on this, but it won't generate it if it doesn't need it. But I've been having really good success with the tree supports, right? That's the tree supports. They seem to break out easier. And then build plate adhesion, I'm just doing a skirt because I'm using a Matter Hackers G10 fiberglass. You get to see that here in a minute with Elmer's glue stick on it, and it seems to work really good. I don't have a heated chamber from my machine, but it is what it is, right? So the other one is special modes, arc welder. I like that for a lot of this stuff for radiuses. So what it's doing, actually you can't see that, there it is. Now you can see the arc welder. When the printer is printing, like that radius, we've got this radius on the edges here. What ends up happening is it splines, right? So remember we were talking about when we saved it as an STL, we've got that half a degree splining, right? So what arc welder does, it's a little post-processing thing in Cura add-on thing. that changes that into a radius. So just it's a different type of G code, because most of the slicers don't use radiuses; they just have splines. So it's angles, right? Just flat spots. So that actually turns it into a radius, and you actually end up with a lot nicer finish on your part. So let's close that, and you can't see because I'm in the way. There's a slice button down here. And slice. And I'm prepping my little USB, or it's a SD card that my printer uses. So to save the disk, which is good because we do want to save. No, save to removable. So it should floor rib punch A is what we've got. Okay, so eject it. Now we've got that card, so let's go ahead and get the machine prepped, and I'll switch over to a different camera here. All right. All right, so 17 hours later, we got parts. Came out pretty good. I got a little bit of elephant's footing on my part. I don't think you can really see that, but it's not bad. I'll tell you what, if you really look inside, I don't know if you can see the details on that. Pretty nice part. Now, because of the elephant's footing, where the clearance holes are for the alignment, there's a little bit of cleanup to do on that. We'll run a drill bit through it, and then let's see if we can go ahead and just do a test piece and see if these things fail or not. All right, so a piece of 18 gauge cold roll, just like what I'm making the floor out of. I think the easiest thing to do is let's just start and see if we can get this thing to produce. We'll lay that on there. We'll mark where our holes are with the scratch awl, right?
Then we'll mark our centers. Automatic punch from old crappy Harbor Freight. Actually works better than the Matco ones. And they're a lot cheaper. Alright. Get it close. And then we're going to drill a hole in it. So let's start off. I'm a big believer in gloves anymore. I use them all the time. I've had too many accidents and the gloves have saved my hands. Not a bad idea. And then we just go through and drill a couple holes in this thing. Nice sharp bit. Okay. Now we're going to do the bigger bit. Clamp the part to the table. Small stuff, not going to catch it, but even a little handheld drill like that, it's going to catch that part and it's going to do the Dougie on you. So clamp it. If you don't know what the Dougie is, don't go looking for it. You're not going to like it. So step up the drill size. Okay, so these are 5/16 holes, so we need to step up to at least to a 5/16 hole. So, right, makes sense. So, the old drill index has seen better days, no doubt about it. There's a 5/16 right there. Should be able to look. Yep. Clear through. Alright, so now with our holes, then it's going to locate our top and bottom. Right? And we're going to put back on the drawing. So we put them together, we see they fit really well. If I turn one of them over, they still fit, but they don't fit quite right because the radiuses are different. But we just make sure if we were going to have something where the radiuses were radically different, we definitely want to be able to mark it so we know which side is which. So let me go find some hardware and we'll stamp it out. So one of the things you need to kind of figure out is your setup. So the bolt heads are going to stick out past the back of this thing. You need to be able to go in something so it sits flat. And I've got a couple of pieces of bar. Made sure that, you know, this will fit on here and we can get it all stamped together, right? One of the things I'm concerned about is pre-stretch. You know, I want to see how much is this all going to shrink up as we stamp this shape into it. How much is it going to move? If we see a lot of movement, we know we're going to have to sit here on the power hammer or hammer and dolly or something. We're going to need to stretch this area until we start getting a bubble. That's kind of one of the first tests we need to do. So we'll go ahead and just get started on this. Let's just go ahead and do a dry run. We know we're probably going to have to do something. We're going back to back. Yep. Alright. Put that on there. And the bolts will push through. One of my favorite things in the world, the hydraulic press. This one is air over hydraulic, but it's noisy. And you just want to see me work anyway. It's kind of the whole point, right? Yeah, I'm using my phone to monitor the GoPro here. All solo. No helpers. Not yet. And as we're getting close, I'm going to change the camera. Get you a little extra light so you can see what's happening here. I don't know, that's terrible, isn't it? I need a light for this thing. I should have brought the good camera. Yeah, it sucks. I don't like it. Anyway, you can see some of it there. Look at that. See how much that thing tacoed up? Alright. Alright, see how bad this is. Come on. Alright, so first look, you can see it didn't do it super clean, right? We knew it was going to wrinkle up some. Just wanted to see how bad it was, so we'll take it over to the bench and we'll pry it apart. Alright, next one's all set up. Let's get ready. I should probably set up the air. I'm just too lazy. And that compressor makes a lot of noise. And I know audio is kind of a precious thing on YouTube videos, so I'll just do this. Find out real quick here if this is enough stretch or if I gotta do more. I know it can't be less. Alright. So what do you think? Really bad? Good? About the same. Yeah. About the same. Huh. Well, let's see how bad this one is. You just have to do a lot more stretching. Come on. Well, if anything, we know the dies work. And critically, you really can't tell the difference between the two. Actually, the first one, this is number 1, this is number 2. Number 2's got better definition in the stamp, no doubt about it. But what I do have is a lot more distortion on this side than I had here. This is about the same. There really isn't much different. So the lesson is, got to do an incredibly more, a lot more stretching. But what is encouraging is, yeah, this definition around this edge, the pocket and everything is so much better. So I wonder how much straightening it's going to take to get this. I'm anticipating I'm going to have to do some straightening on the other part when we get ready, but let's just see how bad it is. So, actually dead wood works great for a lot of this initial. Put it right up against the edge. Yeah. That's interesting. Number 1 and 2. I don't know if you can actually see this. Yeah. Let me see here. Hopefully you can see this. I'm gonna hold that was a straight edge. You can see daylight under that. So it curled it. It shrank it and turned everything. Yeah, nowhere near enough stretch. Alright, so let's try again. We're going to do a combination. We're going to do some English wheel to get our pattern started, get it started to move. And then I think we're going to have to use that gold. It's just going to be noisy. So let's get started. Lay out our area where we're going to put that. Right? Mark where our holes go. We don't want to put the holes in because it's just going to force the metal to go into the hole. And we don't want to do that because we're trying to stretch the metal, not displace it. Right? So mark it, and then we got kind of know where our line's going to be, right? So it's always a good idea to kind of lay stuff out when you got a chance. You know, our start and stop points are about in here somewhere. And it's not going to be super critical exactly where our start and stops are, but we got to kind of have an idea. So let's get wheeling again. All right. Pick up where we left off. Right? quite a bit more on this time, but still not enough. I could keep going. I might do that. And then we'll do a little tune up with the echo. I think we'll just keep going here. Just getting more, just more aggressive on the. Yeah, way more aggressive. You probably even see the machine flex a little bit when I was pushing on that. Pretty rigid structure. All of this is 1/4-inch plate that I made, and it's got a taper, so it constantly tapers all the way down until it gets to about here, and then it starts to tape thin down to this arm. And there's gussets inside, all 1/4-inch. It's all TIG welded. Pretty strong machine. I'm happy with this. I've used a couple other ones. The one I got at work is 4-inch by 6-inch box tube. It's quite a bit bigger. It's probably twice the size of this machine, but the wheels are the same. It doesn't need to be that big. You're not making that many panels that big. Most of the stuff that I'm going to do, man, if it's 8 foot wide, I got a 48-inch depth on this. I'm going to do half and half, and it's going to take at least 2 people to hold it while you're doing it. And they could get a panel any bigger. Getting 3 or 4 people to hold and all coordinate at the same time is just tough to do. You're almost better off doing smaller pieces and welding them together. Look at Bobby welding. See how he does it. That's how he does it, right? And he's using a Yoder. Yeah, he's got a Yoder hammer. Really good guy. I like Bobby a lot. Good instructor. I'm trying to steer it, so I've got the die kind of lined up in the middle of my line there. But I want to spread that load over a little bit more area also, because we're trying to stretch not just in that center. These dies, they have a flat spot in them. I don't know if I like it or not. It ends up making some marks when you're trying to do really low crown work. I don't know. I've heard pros and cons, and I'd like to try a set of constant radius dies, just to see if the tracking marks that it leaves is any better. I just know, I got a lot of post-process work to do. I'm going to use this machine to do a low crown panel. High crown stuff, you can really get it dialed in. Get a pretty good planish on it and stuff, because you don't need to put a lot of pressure on, especially as rigid as this frame is for this machine. It doesn't do a lot of flexing, so you're not doing inconsistent pressure, and you can get a lot smoother finish on this thing. And you can see it kind of flips here. There's like a high spot right there, or a low spot. It's probably a low spot. Yeah, it's a low spot. So the metal's inconsistent in its thickness, I think. And it's got like a thin spot right there in the metal. The amount of pressure I've got on this, there's probably a good 10 tons of pressure at least on here. It's going to make impressions in the metal, and that's what you're going to feel. Especially when it's at pressure that high, you're really going to feel the pressure change when you're rolling over those high spots and thin spots. That's enough. Oh yeah. Oh yeah. Yeah, you see that is where we've done a lot of stretching. So I'm going to hit this on my anvil, and I'm going to use the Eckold, and I'm going to try to push a lot of this extra material up. All right, so now I'm set up. Earplugs in because this is noisy. You probably won't need them because I don't think the GoPro microphone is going to be that good. Old piece of railroad track from my granddad on my mom's side. My dad's had it for a while. I ended up bullnosing it great anvil to work off of. Keep it clean, keep it free from nicks and burrs and stuff, and you'll get less of that transferred into your part. And my Echold, I've got a flat shoe on it, hardened steel, noisy. So let's keep going. Glove up and put a little extra shape in this. I don't know if you can hear that ring when you're on dolly or off dolly, and this is obviously going to be on dolly. We want that ring. We want to hear that, so we can hear it. That's the metal stretching, and you can see the shininess here now. That's from planishing. That's that planishing sheen that you're going to get from that metal being flattened out. You can see I'm trying to stay in my little pattern where I'm going to depress that and offset that. So I'm just going to keep going. Chase the mice around, chase the handle around. So that's the goal. Is you just want to keep going up with it and try to get some stretch in that. Come on, compressor. Chase this thing right off the table. So that's got quite a bit. You can see it's got a lot of crown to it now. So now we want to make our die, right? Still think it's going to be easy. All right, we'll deburr on that and we'll go stamp it. All right, am I in frame? Sort of. All right, so let's try this one more time here. Still curled up some. Let's see how bad it is.